All right, here are solutions for quiz 2 for Math 112. The first problem here, the first section has two problems, and basically what I'm saying is there is an exponential function that goes through these 2 points. Find it. And so for you to do that, you have to know that an exponential function looks like this. F of x equals a times b to the x power. And what you got to do is figure out a and b. And fortunately for you, one of the 2 points I gave you had an x-coordinate of 0. And x-coordinate of 0 and a y-coordinate of 3 tells you that the y-intercept is 3. And the y-intercept is exactly the value for a. So based on that point alone, you can just look at this thing and say, hey, a equals 3. It's 100% true. So then I can go over here and I can say, all right, f of x really is equal to, instead of a times b to the x, how about 3 times b to the x? But we still don't know what b is. But we can figure out what b is from this point here. We can go and plug things in. We know that when x equals -2, y, or f of x, is equal to 12. So I can say that 12 is equal to 3 times b raised up to, instead of the x power, then -2 power. And now I got to solve this equation. I guess I divide both sides by 3 to get 4 is equal to b to the -2 power. And then you have a few options here in terms of how you solve this. There's quicker ways, but maybe the most intuitive way to do it would say, well, b to the -2 power is 1 divided by b squared. And so really, if I'm trying to solve for b, I want to get this b down here in the denominator up to the top. So I'll multiply both sides by b squared, and that gives me 4b squared equals 1. In other words, b squared is equal to 1/4, and therefore b is equal to the square root of 1/4. Note, you should put in a plus or minus anytime you take the square root of both sides of an equation. However, there's restrictions on b. B has to be a positive number that's not equal to 1. So a negative wouldn't make sense in this context. I don't even have to put it in. The square root of a fraction turns out to be the square root of the numerator divided by the square root of the denominator. And the square root of 1 is just 1, and the square root of 4 is 2. So what I figure out, a lot of arrows here for some reason, is that f of x is equal to 3 for a here, times b, which is 1/2, raised up to the x power. And that's part A. Part B is quite similar. The only difference is neither of these 2 points has an x-coordinate of 0. So I don't immediately tell you what A is, so you have to do a little bit more work. The way I like to do it is start with your general form of an exponential equation and plug in these points. So from this point, I know that when x equals -2, y equals -1. In other words, -1 equals a times b raised up to the -2 power. Now from this point here, I know that -16 is equal to a times b to the 2nd power. And we learned this trick in class that says when you have 2 equations and 2 unknowns, you can solve it. And there's lots of ways you can do it. You can solve by substitution, but I think the quickest way, the easiest way, is to divide these 2 equations. So that's the trick we learned in class. If this is the same as this, and this is the same as this, then this divided by this is the same as this divided by this. In other words, -16 divided by -1 is equal to ab squared divided by ab to the -2 power. But some nice stuff happens here. First of all, -16 divided by -1. A negative divided by a negative is a positive, so that's just 16. 16 over 1 if you want, which is just 16. And then these a's cancel out, so I have b squared divided by b to the -2 power. And now you might know this exponent rule that says when you're dividing exponents that have the same base, you can just subtract the exponents. So I want 2 minus -2. 2 minus -2 is the same as 2 plus 2, which is 4. So I get 16 as b to the 4th power, and therefore b is equal to 2. Again, you could put in a plus or minus here, but because of the restrictions on b, b must be equal to +2. My hope is that you know that the 4th root of 16 is equal to 2. That might be asking a bit much, but you have seen in our class that these answers are always kind of whole numbers. So you can sort of check, is it 3? What's 3 to the 4th power? I don't know, but it ain't 16. Okay, maybe 2. What's 2 to the 4th power? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. Looks like that works. Anyways, we're not done here. I guess I shouldn't put a box around this because it's not a final answer. It's just an important step. I know that b equals 2. I now go back up here, either of these two equations, and solve them for a. I'm going to use this equation here. I'm going to take, this is just crazy arrow diagrams on this quiz solutions for some reason. I'm not sure why I'm doing this. I got negative 16 is equal to a times, and then instead of writing b, I'll write 2 to the second power. Note I could have used this equation as well, but then I'd have to deal with negative exponents, which create fractions, which are kind of a pain. So I'm going to use this one instead. So I got negative 16 equals 2 squared is 4. So I got 4a. Divide both sides by 4, and you get that a is equal to negative 4. And therefore, my function, was I supposed to figure out a function for each of the following? Find the exponential function. Fine. F of x is equal to negative 4 times 2 raised up to the x power. All right. That's the majority of the quiz. That is, well, 12. So 12 of the 20 points. 8 more points down here. And what I did down here is I tried to get you thinking about what exponential functions look like without actually having to graph them or solve them. So in our OpenStax text, this quiz was supposed to cover 4.2 and 4.3. 4.2 is kind of this introduction to exponential functions. 4.3 is more about the graphs of these exponential functions. So what I was hoping you were doing here is you don't have to figure out what a is equal to and what b is equal to, just whether a is a positive number or a negative number, and whether b is greater than or less than 1. And the way you can figure that out is sort of picturing the graph of this in your head. So let me give a very rough sketch. Let's see, if x is negative 5, y is 10. I don't know, maybe that's here. And when x is negative 2, y is 20. Maybe that's up here. So the exponential function that connects these guys looks something like this. An exponential function that looks like this, note that the y-intercept is positive, because when I cross the y-axis here, I'm way the hell up here. So that tells me that a is positive. As I read this thing from left to right, it's going up. Its growth factor, it's growing, it's getting bigger. Growth factor is greater than 1 because it's increasing as you read from left to right. So b is greater than 1. So my answer to part A here is that a is positive and b is greater than 1. I can use similar logic on the rest of these problems. Let's see, on this one I got 1 point at 510, so I don't know, maybe that's roughly here. Let's make these a little smaller so they fit better. And then the other one's 220, so I'm way up here. So my exponential function looks something like this. Still has a positive y-intercept, so I would say a is positive. Although now as you read it from left to right, it's decreasing. So it's not growing, but decaying or decreasing. B is less than 1. What about here? Well, same thing, same logic. Switch colors again. Negative 5, negative 10. I don't know, somewhere over here. Positive 2. Whoa, that's not where it is. Sorry, let me try that again. Negative 5, negative 10 would be way down here. And positive 2, negative 20 is way down here. So my exponential function, if I could connect dots a little bit better, would look something like this. And so the y-intercept is a negative number. So a is negative. And as I read this thing from left to right, it becomes more and more negative. So the amount by which it's negative is growing. Therefore, b is greater than 1. It's a little bit confusing. And this last one here, let's see where the points are and what graph it implies. I have 5, negative 10. So I don't know, maybe over here. And negative 2, negative 20. So way down here. So you might have guessed that I'll give you each of the 4 scenarios, and sure enough, that's exactly what I did. Looks like we have another negative y-intercept. So in this one, I guess I should have switched colors, but what are you going to do? A is again negative. But this time, the amount by which it's negative is getting less and less, meaning it's getting closer and closer to 0. So it's not growing, it's decaying. So b is less than 1. So there you go. Those are the solutions. You didn't need to draw the graphs. You just had to give me kind of the logic, or not even the logic. You just had to say this positive greater than or equal to 1. But I showed a little bit more just to kind of show my work. So I guess I'll call that good and end this here.